Below is a revised version of the paragraph with improved grammar, clarity, and engaging language, rewritten over an extended period to ensure careful refinement, approximately 15 minutes. 4 centuries ago, Galileo discovered Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto. Today, we know these worlds are not just distant, icy orbs. Some of them may harbor hidden oceans that could sustain life. Recently, NASA announced that its Juno spacecraft had detected an FM radio signal coming from one of these giant moons. Where did this signal originate? How did NASA uncover it? And what other secrets might Jupiter's moons be hiding? We saw your comments asking for more details about the strange FM signal, and now we're here to deliver. Something remarkable happened as Juno, still exploring the outer reaches of our cosmic neighborhood, recorded an FM radio burst originating from Ganymede. In fact, this is the very same type of signal we use on Earth, commonly known today as Wi-Fi frequencies. Does that mean we've stumbled onto an alien broadcast beaming from Ganymede? To answer that, we first need to understand this intriguing world. Ganymede is the largest moon in the entire solar system, bigger even than Mercury, and if it orbited the Sun rather than Jupiter, it might have been classified as a planet itself. Although it lacks a traditional atmosphere, Ganymede stands out as the only known moon with a substantial magnetic field. It even experiences auroras, influenced by its underground saltwater oceans. The way these auroras sway suggests that Ganymede's hidden oceans are likely liquid and incredibly salty, perhaps even saltier than Earth's. So, what caused this FM signal? Scientists explain that it originates from electrons interacting with electromagnetic fields. This interaction makes the electrons spin and oscillate, producing that distinctive radio emission. In late 2020, Juno picked up a 5-second-long radio burst as Ganymede passed through Jupiter's polar region, where the gas giant's magnetic field interacts with the moon. Could Ganymede host life? While the FM signal isn't alien in nature, and the moon's surface is bitterly cold, about -186 degrees Fahrenheit, there is evidence of abundant oxygen locked in or near its icy crust. When Galileo's spacecraft flew by Ganymede years ago, it detected dense streams of atomic hydrogen escaping from the moon's thin atmosphere. With hydrogen escaping, oxygen is left behind. Some researchers believe Ganymede's surface may hold as much oxygen as Earth's atmosphere. Still, life there would face immense challenges. The crushing pressure at the ocean's base might turn water solid, making it far less hospitable. A dedicated mission is needed to find out more. As intriguing as Ganymede may be, it's not considered the best candidate for life in the Jovian system. That honor often goes to Europa, a bright, ice-covered moon with a crust possibly 2 to 20 miles thick. Europa's surface is extraordinarily smooth. No mountains, no craters. And beneath that icy shell may lie a saltwater ocean holding twice as much water as all of Earth's oceans combined. Europa is frigid, averaging about -260 degrees Fahrenheit, but life on Earth's seafloor thrives near hydrothermal vents, independent of sunlight. If Europa's ocean similarly features vents or chemical energy sources, it might nurture simple, microbial life. Decades ago, the Galileo spacecraft found evidence of a vast, dark ocean beneath Europa's ice. This subsurface sea remains liquid thanks to the powerful tidal forces generated as Europa orbits Jupiter. These tidal stresses also produce heat within Europa's core. Scientists believe liquid water, an energy source, and essential minerals might all be present, forming a recipe for habitability. Between 2014 and 2016, the Hubble Space Telescope spotted what could be enormous plumes of water vapor erupting from Europa's southern regions, reaching about 62 miles high. NASA plans to send the Europa Clipper mission in 2025 to study these eruptions, the icy shell, and the hidden ocean below. The solar-powered $2 billion spacecraft will make 40 to 45 close flybys, using a suite of high-tech instruments to determine whether Europa's conditions could support life. What about Callisto, another large moon of Jupiter? Although it's the third largest moon in the solar system and nearly the size of Mercury, Callisto's heavily cratered surface made it long seem like a dead world. Far from Jupiter's intense magnetosphere, Callisto might also have a hidden ocean beneath its icy crust, warmed and insulated enough to maintain liquid water. But whether it's a viable environment for life remains unclear. To uncover the mysteries of Ganymede, Callisto, and even Europa, the European Space Agency and NASA are preparing the Jupiter Icy Moons Explorer, JUICE. Planned for launch in 2022 and set to arrive at Jupiter by 2029, JUICE will carry the most advanced scientific payload ever sent to the outer solar system. During its 3.5-year mission, it will perform 30 overflights of these icy moons, studying their gravity fields, magnetic interactions, and the potential existence of subsurface oceans. Its goal: determine if conditions are right for life or if life itself could be lurking below the ice. Yet, Jupiter's moons aren't the only tantalizing places to look. Saturn's moon Enceladus has also captured our attention. In 2019, NASA revealed that the ocean beneath Enceladus's thick, icy crust contains life's building blocks: organic molecules, water vapor, ice crystals, and methane, all detected by the Cassini spacecraft. Warm hydrothermal vents on Enceladus' seafloor might mimic the energy-rich environments where life on Earth first arose. A proposed mission, called Orbilander, would cost around $2.5 billion and aims to orbit and eventually land on Enceladus. Its instruments could sample the towering plumes of water vapor erupting from the South Pole, searching directly for evidence of life. Nuclear power sources would keep Orbilander running for up to 18 months on Enceladus' surface, gathering data and sending it back to Earth. With each new mission and discovery, the possibility of life elsewhere in our solar system feels ever more plausible. Whether it's an FM radio-like signal from Ganymede, water vapor geysers on Europa, or organic-laden plumes on Enceladus, we're inching closer to answering one of humanity's greatest questions. Are we alone in the cosmos? Stay tuned, because as our spacecraft venture further and our technology advances, we're bound to uncover more astonishing secrets from these distant, frozen worlds.